Hi, this is a tutorial series to teach you how to make your first game in Gamemaker in 3 simple steps. The goal is to introduce you to the Gamemaker software and its most basic functions so that after you finish these 3 steps, you can learn to make your own games, troubleshoot bugs, and find solutions all on your own. My name is Dr. Sky, and I'm a professor of digital media arts at the University of St. Thomas in St. Paul, Minnesota. This is step 2. In this video, you will learn about adding a score system, sounds, and keyboard controls for your game. Let's get started. Let's add score and score text on the screen. But before we do that, let's just show you what the game looks like thus far. Here we have instructions. If we hover over the blocks, they disappear. If they get to the end of the screen, the game restarts. Now what we want to do is we want to add a score system up here in the top left corner so that every time we destroy a block, it increases our score by 1. So let's go to our title room, our title, in the creation code, and declare a new global variable. Global.points equals 0. Close that. Close that. Create a new object and call it O underscore score, or call it whatever you'd like. Just make sure you have a naming convention that you like. O score. And then in a draw event, draw, where are you at, draw? Write the following. Let's first add a black background to the score numbers or score text so that you'll be able to read it on the screen. So draw, oh, no comment here. There we go. Draw set color C underscore black. Draw rectangle. Top left corner is 0, 0. Bottom right corner is 60 pixels, 30 pixels. And we want this to be filled in, so we're going to say false here or 0, either is fine, but that tells Gamemaker whether we want the rectangle to be filled in or not. So we want it to be filled in, or it's actually whether we want it to be an outline or not. So we don't want the rectangle to be an outline, we want it to be a filled in shape. So we'll write false, say 0 or false there. And did I do everything right? Yep. I'll add a comment here. It's always good to comment stuff so you can know what you're doing. Black background. Add another new comment. Aqua outline to background. Similar to our instructions on how to play the game. Draw set color C underscore aqua. Draw rectangle. And then the exact same thing, 0, 0, 60, 30, true, or you could just write 1. We want that to be an outline. Then display points. Draw set font F instruct. Remember we created this font called F underscore instruct in our last video. Draw set color C white. Draw set H align. FA left. We want to orient it to the left. I believe our instructions are oriented to the center and the middle. This we're orienting to the left. Draw set V align. FA top. So we want our text to be drawn starting from like the top of wherever we put the coordinates instead of in the middle. Draw text wherever our object is located, X and Y, and then string to make a string, or yeah, to create text out of whatever number we put here. Global.points to close parentheses and semicolon. So we're using a new function here called string. The string function takes a number value and turns it into text that can be shown on the screen. Remember, global.points is a variable storing a number and not text. We need a way to change it from whatever number it is, like 0, global.points equals that. We need to change it from like 0 to turning it into a string, which is like this, 0. A string turns yellow in GameMaker and makes it so you can see it on the screen. All right, add a new create event and write it's the location of our score box to be x equals 8, y equals 5. So this is just a little bit away from the top left corner of the room. Now close that, open our game room, and drag our score object under in here in instances. It doesn't really matter where you put it, because even if you put it like over here, when the game opens, we've set its location to be right up here in the top left corner, so that's where it will go. But I'm going to put it up there just so I remember what it is. So like before, whenever we do anything new in GameMaker, we always run the game to see if everything works, and if it doesn't, we know what mistake we made. We put it over here so I can see it. There we go. We see our little score box in the top left corner. Beautiful. Yep. So now we need to make it so the player gets points for bursting those blocks. So in the O block object, in the step event, add the following to where the object gets destroyed by the mouse, which is right here. So right before instance destroy, let's add a new line and write global.points plus equals 1. Now, this is important whenever you're altering variables and you only want it to be altered one time. In this case, we only want it to add 1 point. This line of code, these instructions will only run for one game frame because it gets destroyed immediately after. So we know for sure that it will only add 1 point. If we didn't have this here, this would add new points every frame of the game, and it would rack up really fast. So watch this. If the block doesn't get destroyed, watch the game points in the top left corner. They just go crazy every game frame. Oh, excuse me. But this only runs one frame of the game, so that's totally fine. So we run the game and see if that works. We should get 1 point for every block we destroy. 1, 2, 3, 4, 5, 6. Yep, it's working. And once we get a block to the top, the game starts again, and look, we have that global variable setting to 0. Let's add a little explosion graphic to the blocks. Now this is going to be very, let's say, an introductory level version of graphical panache. But we're going to add little block bits that fly off and disappear when we destroy a block. So let's create a new sprite and call it s_bits. These are the bits that are going to sort of disperse, fly off, or explode. Now, I could go into like a whole video describing what... oh, did I do that under... What? Hold on, I did function on accident. Here, let me delete that. See, it's important when you right-click a folder, that's just telling GameMaker where to put the resource, but you can create any of these resources and put them in any of these folders, so things can get confusing. So I urge you, if you right-click sprites, make sure the only thing you're creating in sprites are sprites. I accidentally created a function. So let's call this s_bits. And let's change the canvas size to 10 and 10. Apply 10 pixels by 10 pixels. Let's put the origin to middle center. Right now, there's nothing to be seen. We need to color it in. Edit image. Let's fill it in with a bright red color for now. Boom. Close that. Let's create an object. I always forget where the objects are. There we go. Called O_bits. Assign that sprite. And now add a create event and write destroy bit after 20 frames, alarm 0. need square bracket equals 20. We've covered alarms already in the previous video, so you should know what they are. And then another one, set speed to 6 per frame. Speed equals 6. We've also covered what speed is in the previous video, but again, if anything gets highlighted in Gamemaker Studio and you want to learn about what it is, just click with your mouse wheel on the thing, and it will open this awesome manual that will describe exactly what it is, how it works, give you examples. This manual is wonderful. It is fantastic. I urge everyone to look through that manual and right-click things and learn how they work, because the documentation is really good. So we've set an alarm that destroys this bit after it gets created after 20 frames. Now, at this point, nothing is making the bits appear in the game, but we'll do that in a moment. Right now, let's just set up everything in O bits. Alarm 0. Let's write instance destroy. Oh, one more thing. In O bits, let's add a step event. And write a little fade out animation. So when it flies off from the block, it doesn't just disappear when it gets destroyed. It'll kind of like fade out. So if image alpha is greater than 0, image alpha minus equals 0.05. Image alpha is a built-in variable of the object. If the object has a sprite image, which this does, it will change its alpha value, meaning its transparency or how transparent it is. So if this if statement checks to see if the object's sprite's alpha value is greater than 0%, meaning you can see it, then it reduces how visible it is by 5% every frame of the game, 60 frames per second. So we'll change it from 100% visible to 95% visible to 90% visible to 85% visible to 80% visible. And it does this every frame of the game. So it actually happens quite quickly. So just because you can't see something in the game doesn't mean it's actually there. Of course, you have things like the instructions object and the score object and other things in the game that at sometimes you can't see, but other times you can. Just because you can't see something doesn't mean it's not in the game. That's why we added this instance destroy to destroy it. So just because if it faded out, the game would still be checking its code every frame of the game, and that's just an unneeded burden on the processing power the game needs. So that's why we make sure that things get rid of themselves if we don't need them anymore. Now let's create a new object and call it OExplode. Now this is the object that's going to make the bits appear and fly out from the blocks when we destroy them. And add a create event so that when this object gets created, it does everything we need to do for the explosion. Now we're actually going to make the block object make the explode object, and the explode object is going to make all the bits appear. Now it's a little bit redundant, but it kind of makes sense in a bit that we have just a single object that does the explosion for us. And we're going to write the following code with a little bit of copying and pasting. Now, this isn't going to be the final code we use in the game, but I want to use it as an example. So it's important that you follow along. Let's create a variable called bit1 equals instance create layer xy instances o bits with bit1 direction equals 0. See if this little thing disappears. It does. Now let's just copy and paste this and change a few things. I pasted it 3 more times, so we have 4 total. We'll call this bit1, bit2, bit3, and bit4. Change this to bit2, bit3, bit4. Change the direction 90, 180. We covered direction in the previous video as well, but just as to help you remember, the 0 direction means to the right, 90 means up, 180 means to the left, and 270 means down, and then everything in between 0 to 359, which is 360 degrees, is sort of everything in between. So this will create 4 bits that will fly off in 4 opposite directions, and then after that, we don't need this explode object anymore because it's done everything we need it to do, so we write instance destroy. And these 4 bits will get created, fly off, and then after 20 game frames, they will also destroy themselves. So when an instance is created, I got to explain this really quick. Like we're creating these instances of the O-bits object. When an instance of an object is created, GameMaker gives it a unique identifying number or an instance name. We use the function instance create layer like this, meaning like assigning it to a variable, so that GameMaker gives this variable or assigns this variable whatever identifying instance name or number it gives this instance. So in other words, the game is going to create an instance of the O-bits object, and also secretly it's going to give it a name that you don't normally get access to, but then it's also going to assign that name to this variable so that with this with statement, we can alter that one instance's code a little bit. So then it says, hey, with that one instance that you just created, GameMaker, set that one instance to have a direction of 0 degrees. With statements are very powerful in GameMaker because they allow you to alter the code of other instances and other things in the game. So let's close that. That's everything we need it to do. And one more thing that we need to do before checking to see if everything works, we're going to open our OBlock object. And right before instance destroy here, we're going to write instance create layer XY instances O explode. So right when we hover over the block, we will get a point in the game. It will create the explosion object and then destroy the block. When the explosion object gets created, it's going to create these 4 little bits that will fly off in 4 different directions. Then it's going to destroy the explosion object. And then these 4 bits are going to fly off in their 4 directions and then fade out here in the step event and then destroy themselves after 20 game frames. So let's see if it all works. So let's get some blocks on the screen. You should see 4 little red squares appearing and flying off in 4 different directions. And the point system works. Beautiful. Lovely. Now, this works. I'm going to leave that alone. This works, but you know what would work better? A for loop. For loops are great at reducing repetitive code. And you see how repetitive this code is. It's not very elegant. A for loop has 4 parts. First, it creates a variable and assigns that variable a value. Like, let me get down here to give you an example. A for loop does this. First, it like creates a variable and gives it a value. Say like the variable is I and we give it a value of 0. Then what the for loop does, you don't have to write this, by the way. This is just an example. Then something is evaluated to be true or false. A condition is evaluated just like an if statement. It's evaluated if it's true or false. Like if I is less than 10. Let me write this. And then if that is true, it runs code in these brackets, code to run. And then a statement is performed, whatever statement we want. In this case, we can make that statement to increase that variable by 1. And all of this happens during a single frame of the game, and it happens over and over. So if I equals 0, this code will run 10 times in a single frame. It will check it, do it over and over and over again. So this is what a for loop actually looks like. So for I equals 0. semicolon, I is less than 10, semicolon, I plus equals 1, open and close curly brackets, instance, create layer x, y, instances, O bits. So it assigns a variable. It checks to see if a statement is true or false. This is true. If it is true, it runs this code, and then it performs a statement. I plus equals 1. So it'll go back here. I is now it goes back here. I is now 1. It's still less than 10, so it runs the code again. Adds 1. Now I equals 2. Still less than 10. Runs this. Goes back here. Now I equals 3. Still less than 10. So it does it 10 times because we've set this to be 10. And all of this happens in a single frame. Boom. 10 bits of code run out in a single frame. So now we can consolidate all of this bulky code into a single for loop. So let's delete everything here. Everything before instance destroy. But keep instance destroy there. And then write for bit dir. This is the direction that the bits are going to be flying out. Equals 0. So we're creating a variable, assigning it a value. Bit dir is less than 360. And then I'm actually, before I write the last part, this is the code we want it to run right here, but let's go back here. Bit dir plus equals 90. I'll explain all this in a moment. So the code we want it to run in this for loop be var bit, so a local variable, equals instance create layer x, y, instances, O bits with this local variable bit direction equals other dot bit dir. So let's walk through this for loop and then I'll explain other really quick. So first, part 1, bit dir equals 0. This is creating a variable and giving it a value. Part 2, bit dir is check to see if bit dir is less than 360. This evaluates a statement to see if it's true. Here it checks to see if bit dir is less than 360. Part 3, if the statement is true, which it is, it performs this code in the curly brackets, essentially creating an instance of O bits and giving it a direction. I'll explain how in a moment. Part 4, a statement is performed. Bit dir plus equals 90. So every time this for loop loops, this code runs. It adds 90 to bit dir until it reaches 360. Then it stops. And it does all of this in a single frame. So we're going to run the game to see if it works, and then I'm going to do some more explanation. The exact same thing should happen as before. Yep, 4 bits fly off in 4 different directions. Now, let me explain why that is. Also, I haven't explained what a local variable is. So this yellow variable preceded by the word var, this creates a local or temporary variable. These variables are really useful. They get declared with var space variable name equals whatever value, and then it only exists in the game's memory for that one frame, and then the game forgets it. It's a great way if you want to use a variable quickly, but you don't want to declare it more formally. And one more explanation with other dot bit dir. Using other lets us refer to the instance that is using the with statement. So we use other in with statements. So the object that's using this with statement is oexplode. So if we want to refer to anything from oexplode, like this bit dir variable, but we're in a with statement, which is altering the code of this instance right here. We just say other dot and then whatever variable that we want to mess around with. So what's elegant about this for statement is that it lets us easily change things without altering a bunch of different lines of code. For instance, let's make it so 8 exploding bits fly out instead of just 4. All we have to do is change 90 here to 45. Now we'll have bits flying out at every 45 degrees until it reaches 360. Test the game. Now we have 8 bits flying out. For loops are very powerful. They're not very intuitive, but once you're figuring, if you're ever like doing a bunch of repetitive code, it's useful to figure out how you can use a for loop, or a little while later I'll teach you about what while loops are, which is like a simpler version of this. But that's for another time. So at this point, you have learned a few bits of information here. You've learned about the string function. You've learned about image alpha, instance names or identifying numbers. You've learned about with statements, for loops, local or temporary variables, and the use of other within other dot variable name within a with statement. So now let's add some sounds to the game to make our game appear a little bit more lively. We're going to be using sounds that I made, but you can make sounds yourself. I use a little sound effects maker online. You can just Google 8-bit sound effects maker online. You'll find a bunch of different systems to make sounds. But I've already pre-made everything. So just in that game resources folder that you should have downloaded already, you should find these sounds. We want 2 sounds here. We want a block breaking sound. So every time a block explodes, we get a sound, and some background music. First, let's go to sounds, right-click sounds, create sound. Where are you out, sound? There you are. I'm going to call this, let's see, SND underscore break. Now, I don't want to do S underscore break because I use S underscore for sprites. So for sound, I do SND for sound. So this is the sound for when a block is breaking. So sounds are exactly what they sound like. They're just assets in the game that we use to make sounds in the game. Now that we've created this asset, click the 3 little dots here, and let's choose a sound from my computer. So my folder for first game files is just on my desktop. So there should be 2 sounds in that folder, and one of them should be called block burst. So I'm going to click that, and that assigns a sound. You can actually play it. Let me see if you're actually hearing it. You are hearing it, good. You can also alter the volume here, but we'll get to that in a moment. Now we have created the sound. We can call on the sound. It's just called SND underscore break whenever we want to in the game. So in the oblock object, right before instance destroy, let's add a new line and write the function audio underscore play underscore sound, SND underscore break, comma, and then it's we need to set its priority, or how important the sound is. You can't play an unlimited number of sounds at the exact same time in Gamemaker, so you have to set the priority. But in this game, we only have 2 sounds, and Gamemaker can totally handle 2 sounds at the same time. So we're just going to put the priority as 1. Doesn't matter. And then, do we want this sound to loop continuously? No, we just want it to play when the line gets run. So this line of code gets run, so I will write false. We don't want it to loop. So there's 3 arguments in this function. This is the sound ID. This is its priority, which I've already explained, and this is whether we want the sound to loop or not. Now that we have this sound here, let's run the game, see if it works. It works. Now, this sound might be a little loud. To adjust the volume, open the sound asset, and here under volume, you can just like reduce it a little bit. It just, I don't know, down to like 76 or something. Now let's just see if that sounds a little better. A little better. You can even make it even quieter. Now let's add some music. So let's create a new sound. Right-click sounds, create sound. Call this one SND_music. And we can just use some music that I wrote for another game of mine. And it's called Easily Defeated. And we have that sound asset created. Now we can open our title room. And in the creation code, before we tell the game to go to our game, let's add some code, play music, we comment, and then we write if bang or exclamation point. It's called a bang in code for some reason. Audio underscore is underscore playing. So this is a function to see if certain sounds or audio is currently playing. And by adding a bang before that or an exclamation point, we're checking to see if this audio is not playing. So this is saying, hey, if the music is not playing, do the code. Audio, play, sound, send the music, priority of 1, and we do want it to loop, so we write true. See if this is all good. Yep, it's all good. So we want it to repeat after it finishes. We set the loop to true. That should be it. Let's run the game, see if we hear some music. We do. That's it for sound. The only thing to watch out for is making sure that a sound doesn't repeatedly get played, especially in a step event, because remember, in step events, that code runs once every game frame, which in this case is 60 frames per second. Both of these sounds are being played in code that makes sure it only starts playing on 1 frame right before a block is destroyed, and then during the creation code of a room. For example, if we wanted a sound to play when the instructions just begin to fade, we couldn't just add it to the top of the show text if statement. It would play a new instance of that sound every frame, 60 frames per second, while it fades away. To show you why that is a bad idea, let's try it. Open o_instruct in the step event. Underneath the if show text is false, if statement, add, let's see, right here. Right at the very top, right? Audio, play, sound, SND, SND break, 1, false. Oh, I'm just SND break, comma, 1, comma, false. So we're saying, hey, we don't want this sound to loop, so it won't loop, right? It'll only play once right when the instructions start to fade out. Let's test it and see why that's a bad idea in terms of where I put it. So this will start fading away. So you heard that? That was the break sound playing every frame of the game while the instructions faded away. And that's because it is running this code right here 60 times per second. So when you're setting a sound to play, make sure that it's you have some contingency to make sure that that code only runs 1 time. Like right before an instance gets destroyed, or there's a system where you can create a variable like a Boolean, set it to true, and then right after you create the sound, set that Boolean to false, so it immediately doesn't run that code anymore. So there's ways around it. So at this point, you've learned about sounds, the audio play sound function, and the audio is playing function. And in this case, we wrote a bang before audio is playing, so its audio is not playing. Let's now make an object we can control with the keyboard to burst these blocks. So in this game, we're going to make it so we don't use the mouse to hover over blocks. We're going to have an object we control in the game that we control with a keyboard to burst the blocks. Let's create a new sprite. Call it s_terminal. We're going to call this object the terminal and set the sprite accordingly. I'm going to go to import, and you will see these terminal things, 1, 2, 3, 4. There's 4 of them. So I'm going to highlight all of them and hit open. Hit yes. Set the origin to middle center. Oh, middle center. There we go. And close that. create a new object called O terminal, set the sprite accordingly. And in a step event, oh, what happened to you? There we go. In a step event, write the following. Comment get inputs for keyboard variables. So I will explain all of this in a moment, but I'm going to write all of it in one go. We're going to create a variable called we're going to use a variable called key_write. We'll declare it in a bit. Keyboard_check vk write. Key left equals keyboard check vk left. Key down equals keyboard check vk down. Key up equals, oh, forgot here, key left, I want this to be negative keyboard check vk left. Be sure to alter that, the negative keyboard check vk up. Whew. So keyboard check, this function here, returns either a 1 or a 0, depending on whether that key is being pressed every frame of the game when it's pressed. So if we set a key left or a key right variable, if we set key right here to check the right key, so vk_right means the right arrow key on the keyboard, every time that button is held down, this will assign this variable to be 1. And when we let go of it, it will continuously assign this variable to equal 0. Now, by adding a negative before this function, negative keyboard check vk left, it will assign it to be -1 whenever the left arrow key is held down, or -0, which is just 0. Now, this is going to be important in a moment because we are going to write calculate horizontal and vertical movement direction. Variable hmove equals key_right plus key_left. And this is -1, 0, or 1. And then let's do the same for v_move key down plus key up, semicolon, comment, -1, 0, or 1. So what this does is that it adds together the variable for key right and key left. Now, think about it for a moment. If key right is being pressed, that is 1 plus whatever key left is. So if key left is not being pressed, this is 0, so it'll be 1 plus 0. Hmove will be assigned 1. If key left is being pressed, it will be -1. And if key right is not being pressed, it'll be 0 plus -1, or 0 minus 1. So hmove will be assigned -1. If neither of these buttons are being pressed, it'll be 0 plus 0, so 0, or 1. If they're both being pressed at the same time, it'll be 1 minus 1, which is also 0. So for this, we're telling this variable -1 to move left, 1 to move right, or 0 to not move horizontally. Now the same thing goes for vertical movement. How fast and in what direction. HSP, which we're going to use for horizontal speed. Be sure not to write hspeed, because that's a built-in variable or an instance variable or a built-in property. We're going to write HSP for our own variable equals h_move times move speed. VSP for vertical speed equals vmove times move speed. So we're going to assign a variable to be the move speed in a moment. And then comment do it. Change this object's X and Y positions. x plus equals HSP, y plus equals VSP. All right, so we check to see which keys are being pressed or held down. We do a little bit of simple math to determine which horizontal direction we want our terminal to move, left, right, or not at all. And not at all can be either no keys are neither key is being pressed or both keys are being pressed at the same time, so they cancel each other out. Same with vertical. Then how fast? Whatever direction, which is h move, multiply it by the move speed. So if the direction is -1, it'll make a negative move speed. Say we set the move speed to like 2, it'll be like -2. And if vertical move is positive, it'll mean a positive speed. If it's negative, it'll make it a negative speed. And then it will commit those values to the x and y positions. So if we set the horizontal speed ultimately to +2, it'll move this object 2 pixels to the right every frame, or 2 pixels to the left if it's negative. And then same with the vertical speed. Well, we need to declare a few of these variables, so let's add a create event and write key right equals 0, key left equals 0, key down equals 0, key up equals 0, h move equals 0, v move equals 0, HSP equals 0, VSP equals 0, and moved speed equals 4. You can change this to be however fast you want it to be. How fast? Higher is faster. And now we've declared all of our variables. This system should work. The last thing we need to do is open our game room and add our terminal to the game. So I'll add it to like the center there, and let's run the game and see if it works. So I'm pushing the arrow keys, and it works. It's moving around. Now, it's not bursting the blocks yet because we haven't added that code, but right now we just want to see that it's moving. Now, one thing that we should probably do is the animation for this terminal sprite's a little fast. Let's see if we can set the frames per second. Yeah, it's set to 30 right now. Let's change the frames per second to 4. 4 frames per second. That should look a little better. There we go. That looks a lot better. And I'm just pressing the arrow keys and I'm moving around. Now, if I press both right and left keys, it doesn't move. And I press both up and down keys, it doesn't move, which is what I wanted. All right, now it can move. Let's make it so it bursts the blocks instead of the mouse. In the O block object, in the step event, change if distance to point XY for the mouse to if place underscore meeting XY O terminal. Place meeting is a great function that checks if an instance of an object is overlapping at all with an instance of another object. So if this is the O block object, my left hand, and my right hand is the terminal, it's saying, hey, is the terminal overlapping me? No. Is the terminal overlapping me? No. Is the terminal overlapping me? Yes, it is overlapping. So run all of this code. So let's run it and see if it works. Yep. Every time it touches any of these blocks now, the blocks burst. And now my mouse doesn't do anything when I hover over it. In the O instruct object, let's change the instructions to read. Do I have text here? Draw. There we go. Let's change the text to be, instead of using your mouse, let's write use the arrow keys to move and break the blocks! Exclamation point. Now we want the block explosions to be on top of the terminal object. To decide what objects appear or what instances of objects appear on top or behind other instances of objects, we create different room layers, and the topmost layers appear on top of other things. Like if you've ever used image editing software, it's the same idea. So if we open our game room, under the layers section of our room editor, we see we have an instances layer and a background layer. Now our instances layer, we can add several instances layers, we can add several background layers, and you can see a bunch of different types of layers down here that you can add. The one with the 2 circles is instances, and that's the only one we want to be messing around with right now. So this button right here with the 2 circles, create new instance layer, click that, and it should appear at the very top, and it's automatically given a name, but you can highlight it and hit F2 on your keyboard, or right click and go to rename layer. I just hit F2 because it's faster. And rename it top layer. Make sure you pay attention to capitalizations and lowercase letters. And let's rename this other layer bottom layer. So whatever instances appear in this top layer will appear on top of whatever instances are in the bottom layer. Now with more complicated games, you can have dozens upon dozens of different layers to manage things, and if you follow any of my other tutorials, you will see that in action. But this is an introductory first game tutorial, so we're not going to make it too complicated. So now do the following. First, delete O_score, O_control, and O_instruct from the bottom layer. Right here in the room editor, if you highlight these layers, you can see which instances which instances are currently placed in that layer. So if we highlight top layer, no instances are in there because we just created it, but under bottom layer, we have 4 instances. We have O_control, O_instruct, O_score, and our terminal. We want to delete these top 3, O_control, O_instruct, and O_score. So I'm going to highlight those and either hit the delete key on my keyboard or right click. Oh, doesn't allow me to right click? I just have to hit the delete key on my keyboard. Yep, just to hit the delete key. Delete those after you highlight them. Okay, next, click top layer and drag those 3 objects back in. O_instruct, O_explode, O_explode. No, O_score, not O_explode. O_score, O_instruct, and O_control into the top layer. Close out of that for now. In the O_control object in alarm 0, change the layer from instances to top layer. In O_block, in the step event, change this layer name from instances to top layer. Close that. In O_explode, in the create event, change this layer name from instances to top layer. Now run the game, see if everything works. The O bits are now appearing on top of our terminal, even though they fade away so fast you don't really tell, but layer management and managing which objects are on top of what other objects is going to be very important in Gamemaker and other games that you make, so it's an important habit to get into, managing your layers. So, at this point you have learned about keyboard check, place meeting, room layers, and how to add new layers to rooms. And that completes our second tutorial. In the next tutorial, we're going to be finishing the game. Good luck.